Assalamualaikum warahmatullahi wabarakatuh. Hi, welcome back with me, Gita, and my assistant code is GIT. So, today we're going to learn the second module. Let's talk about microcomputer, analog and digital sensor. The purpose of this module are to understand types of analog and digital sensor, to understand the works of analog and digital sensor, and also capable to do implementation of analog and digital sensor with Arduino. Okay, first is sensor. Sensor is a component that functions to detect changes in the surrounding environment and produce output according to its function. The sensor is the main component of a transducer. The transducer is a system that complements the sensor, so that it has the desired output. There are two types of sensor. The first one is analog sensor, which transmit information in the form of a continuous quantity. The other one is digital sensor. Digital sensors transmit information in a binary form, namely 0 and 1. So here's the example of analog sensor. This one is temperature sensor, this one is light sensor, and this one is pressure sensor. Next, let's talk about ADC. Stands for analog to digital converter. ADC convert analog input into digital codes. The function of ADC is to convert analog signals into digital signals. ADC is used as an intermediary between analog sensor, such as light sensor, temperature, pressure, and so on, and then measure using a digital system. ADC Arduino. On the Arduino, there are analog pins that can be used for digital input and output. The analog pin has a feature to convert the incoming analog signal into a scalable digital signal. The digital pins on the Arduino can only recognize 0 volt as a low value and 5 volt as a high value. Arduino analog pins are connected to a converter on the microcontroller, namely ADC. ADC converts the analog value in the form of voltage signal into digital or numeric form so that the analog value can be used more easily and can be applied. As you can see, this is Arduino Uno. Here's the power pins. Next to power pins, there's 6 analog input pins from A0 until A5. In here, you can see the digital pins. There are 14 digital pins. Okay, next. ADC Arduino. There are the important things in ADC Arduino. The first one is the sampling rate. The sampling rate states how often the device is able to convert an analog signal into a digital signal within a certain time interval. The other one is resolution. Resolution is the state level of accuracy that is owned. On the Arduino, the resolution is 10 bits, or in digital value range is between 0 until 1023. Okay, the ADC process. There are 3 steps in ADC process. The first one is sampling. Sampling is the process of taking a definite value or discrete in a continuous data at a certain point in time with a fixed period. Next is quantization. Quantization is the process of grouping discrete data obtained in the first process into groups of data. Last is encoding. Encoding is transform quantized data into digital form or in a binary value, which is 0 or 1. So here's the ADC equation. This equation is used to find the value of ADC data. ADC data equals to voltage in divided by voltage reference, and you just multiply it with maximum data. And also here's the guide table. You can see the guide table here. We've talked about analog sensor. Now let's talk about digital sensor. Digital sensors are sensors that produce a discrete output signal. Discrete signals are non-continuous with time and can be represented in bits. A digital sensor usually consists of a sensor, cable, and transmitter. Digital sensor is a sensor that produces digital output, which is sending a number in binary. It's 0 or 1. So here's the example of digital sensor. It's RFID, this one is peer sensor, and this one is ultrasonic sensor. That's all from second module. You've learned the theory, so see you at the practicum. And also thank you for watching this video. Don't forget to like, share, and subscribe. Bye!